Hi, everyone. I don't know if you knew, but there's more than one way to crack an egg. Just saying. So today we're going to be solving exponential equations. Our learning goal is going to be, we're going to be solving exponential equations using the change of base formula, change of base, supposed to be an important one. Solving exponential equations by taking the log of both sides. I don't know if you knew that, but we can. And what does that mean? We'll soon find out. And analyze different solution strategies to solve exponential equations. So if you're one of those people who are like, I need an example, there's lots of examples here, lots of good examples. All right. And so on the left is our warm up. And if you notice right here, this is, what is it called? Yeah, we're just figuring out what X is, right? And if you can think to yourself, well, what will give me a 30, what would X have to be to give me a 32, right? And let's use blue. So if you notice right here, we just change this to that. So that's the same base. So that means if 2 to the 5th power is equal to 32, then this X better be 5, right? And you do the same thing for all of them. So just make sure you have the same basis and you can figure out what your X is. Well, what if you don't have a base? You're gonna have to figure it out. So plug in some numbers. Something to the 3rd power is 27. So spam numbers, right? Don't go very big though, because they get big really fast. So like even X to the 7th power, yeah, I would try 2 first. I wouldn't try 1 because, you know, 1 to the 7th power is not that fun, just 1, right? So try 2, and sure enough, 2 to the 7th power is 128. I know, crazy. So there we go. Let's see here. So don't burst my bubble, peoples. But that is the newest online game. It's Bubbles Burst. And I don't know if they say this right, because they're like, okay, so apparently it's a very addictive game. That's what it says. Don't Google it. It's not there unless it is. So it says before the game was even released, there were 50 early subscribers. I don't know, do we call it subscribers or would we call it like downloads? But anyways, that's just my thought. But anyways, the creators estimate that everybody who subscribes will then send 3 more people invitations to subscribe the next day, or download, or what have you, right? But either way, 3 more. And we're going to assume that all 3 of them are going to subscribe or download or whatever it is, right? So anyways, so on its first day, it had 150 subscribers. And notice that I did scribble out the word new, because we're not going to talk about news. We're going to talk about whole, in the whole, right? Not just new subscribers. Because if we talk about just the new subscribers, then some of the questions later on will not make any sense. So we're just going to scribble out new. Okay, and if you take a look at this right here, so we're going to write down an equation. So y is equal to a times b to the x power. This is our basic exponential equation, right? And so notice the a is our 50, right? Because that's what we initially start with. 50, a is our initial amount, which is 50, right? Those are probably like our beta testers or whatever. And then b is going to be how much we multiply by, right? So how much does it grow? It grows 3 times, right? 3 times every time, right? Because each one of those 50 players are going to send out 3 invitations, and those 3 people who are invited, and we're not assuming that the same people were invited, you know, right? So this person's not going to invite the same person as this person right here. So, and those are just, so it's 3 over here, 3 over here, so 50 of them. So do you see how, and then those new invites, right, are going to invite 3 more people. Do you see? Keeps on multiplying by 3. All right, so here, this is our equation right there. So how do we check this? Yeah, pretty easy. We just, because we know that on the first day we have 150 subscribers. So that means that P of 1 better be 150. And if we plug in 1 for T, go 3 to the 1 power is 3, then 3 times 50 is 150. Happy days. So it works out. So this is about like what our graph is going to look like. We didn't graph it. You can certainly do it. It's just these numbers are huge. So we're not doing that right now. So what we wanted to do was, on what day will Bubbles Burst reach 4,050 subscribers? Okay, what would that be? And somebody found it, there was like 4. It only takes 4 days. Can you believe it? 4,000. That would be amazing, right? You're on your way to being viral. Yay. So, although viral, that doesn't sound like a good thing. The virus. You don't want to be a virus. But anyways, on what day will Bubble Burst reach 20,000? And so people tried 5. They tried 6, and 5 was too low and 6 was too high. And so we're like, we found some numbers in between, right? And we tried like 5.5 and that was too high, 5.4 and that was too low. So we knew it was between 5.5 and 5.4. And we kind of just kept on making those smaller numbers. So the question is, how do we get the exact number? Like, when does that happen? We know it occurs in the sixth day, right? Because it's 5.5 days. So it's on the sixth day in like the middle of the day, but we don't know exactly when. I just want to know, can we be more exact? And why do we have to do it this way, right? Because we're just literally plugging in numbers to get it to as close to 20,000 as we could. I would recommend you try that. Pause, see how far you can go. Makes it interesting. It's like guess my number. So in order to do that, we need this. Okay, so the change of base formula. Now, if you don't know the change of base formula, but just know that this is true. Okay, and we'll prove it in a bit, but just know that this is true for now. So this is like the generic form right here. This is the generic form. What I want you to do is write this one on your book. Okay, so log base B of C. So this is assuming any base. So it doesn't have to be just 10. It doesn't have to be E. It could be like 2 or 3 or 4 or 5, whatever, right? So the way you can calculate that out is log of C over the log of B, right? And notice that this is base 10, right? So we can it's the common log, right? It's the log that almost everybody uses. So log of C over log of B. And notice that the C is that's the bigger letter here. That's the one on top. The smaller letter, the B, is on the bottom. B for bottom. All right. So we're going to use this to kind of help us figure out, well, what day is that exactly? What is it exactly? So if you notice right here, we have 20,000 is equal to 50 times 3 to the T power, which is what we had. And then we can't just convert to log form right here because we have this 50. We got to get rid of it first. So we're going to divide both sides by 50. So you get 400 is equal to 3 to the T power, right? Make your triangle of power. So there's 3. I know that doesn't look like a 3, does it? So let me make it look like a 3. So here's 3 to the T is equal to 400, right? And then we're going to go in this order right here. So it's going to be log base 3. The next number is 400 is equal to what I'm pointing to, which is T. All right. And now we can use our change of base, right? Our change of base is log of 400 over log of 3. Okay. And then on our calculator, so here's the calculator. If you look at here's the log right here, log of 400. Notice that it opens up a parentheses automatically, so you need to close it. Divide that by log of 3. Here you don't need to close it. You can if you want to. You don't have to, just because there's nothing after that. So and it would be 5 points. So this would be the more exact one. 5.453666056, and et cetera, et cetera. It doesn't stop there. It just keeps on going. But I want you to get used to rounding to the nearest 10,000th place. How many places is 10,000th place? 4. Because how many zeros does 10,000 have? 4. That's how many decimal places it is. If you look right here, this 6 is going to round up, right? Because it's closer to the 7 than it is to the 6. So that's good. That's why we have our answer here as 5.4537. Okay, about. So that's like our approximately, right? So about 5.5 days. All right, so we're going to move on. We're going to do a bit of skipping here, if you don't mind. So now Tammy has to do the exact same thing, except for now instead of 20,000 for 30,000. If you notice her answer is 2.3. There's no way. It doesn't even make sense, because to get to even like, what was it? 20,000, we needed 5.5 days. So it should be longer than 5.5 days, right? Make sense? All right, so here we go. So Tammy, she set up her equation. 30,000 is equal to 50 times 3 to the T. Again, divide both sides by 50. And if you notice from here, what she does to get to the next step is change to log form. So remember our triangle of power, 3 to the T is equal to 600. So notice log base 3 of 600 is T, just like how we've been doing, right? And then so she wrote down, she did the change of base. So this is log of 600 over log of T. And notice here, that's 600 divided by 3. You can't divide that because that's not actually 600 and that's not actually 3. What is it? It's the log of 600 and the log of 3. Just like right here, we said this is the square root of 2. Square root of 2 is not equal to 2, right? Because if it was, then why would we have the square root there? It's actually like 1.3414, something like that. I don't remember. But yeah, so this is not actually 2. It's a facade, right? It's actually the square root of 2, which is something different. It's a different number. So we would not be able, so we wouldn't be like, oh, square root of 2 over 2. Okay. Oh, this is just 1. No, can't do that. Okay. That is not a thing we can do. Okay. So just remember that. So the same thing here. So we cannot do log of that. So you're just going to use your calculator and you're going to go log of 200. Oh, not 200. Just kidding. Log of 600. Divide that by log of 3. Please, if you did not try it on your calculator, try it on your calculator. Whatever calculator, even for your phone calculator, Desmos, right? On Desmos, you can actually find the, what is it called? You can find the log. You can just type it in if you want to, and then, or you can just, it's under functions and miscellaneous. Go there, it's like towards the bottom, just saying. All right, so there's that. And they're rounding this to 10th place, so we're just gonna keep that 5.8, about 5.8. So it's a little, it's still in the 6th day, it's just a little bit later on in the day. All right, and then so right here, in 2017, right, there were approximately 326 million people in the United States. So assuming, you know, let's assuming that was true at that time, and we're back at that time. How long would it take for everyone in the country to subscribe to Bubbles Bursts? Right, so we do the exact same strategies, and you'll know it's not even a whole month. It's barely 2 weeks, right? It's on the 15th day. This is what's going to happen, right? It's going to reach everybody in the whole United States. Crazy, right? It doesn't take long. That's what I'm saying. Exponential does not take long. All right. Okay, so now if you take a look at this, so number 1, we're on page 201. If you notice right here, is the same thing as our do now, right? So this is the x has to be 6, right? Because 2 to the 6th power is equal to 64, right? These are pretty easy. Y to the 3rd power, what could that be? 5. Let's try 5. Right? If you didn't know that, try 2, then try 3, try 4, and then try 5. See if it gets to 125, right? And there you go. So 5 to the 3rd power is going to give you 5. So notice right here that if 2 to the x is equal to 2 to the 6th, well, x better equal 6, right? Because they're the same thing, right? It should, if it's equal, if we said x equal to 5, then 2 to the 5th is equal to 2 to the 6th. That makes no sense, right? Okay, so knowing that, take a look at the number 2. What is W and what is M? Okay, I know see the answers there, but what is W and what is M? If you notice, everything in the green is exactly the same. Log base 3. One time it says W and the other time it says 20. So that means W better equal 20, because if it's not, like if it's equal to 19, that doesn't make any sense, right? It's kind of like, it's a lot easier than you think. So if you look right here at the pink, right? So the arguments are both the same, they're both 9, and we both have logs there. So which means that this M better equal 4. So if it's not equal to 4, what are we doing, right? So now knowing that, so we said that if log base B of A is equal to log base B of C, then this A has to equal this C, right? They have to be the same. So therefore A is equal to C, right? Just like how we said W is equal to 20, right? W is equal to 20. All right, so now the converse is also true. We're going to flip that. So if we know A is equal to C, that means that we can basically log both sides and they will still equal each other. Okay, so this is what we're going to do. So it's kind of like when we square root both sides, or when we cube root both sides, we can log both sides as well. You know, right? Did you know that? So taking the log on both sides of an equation keeps the equation balanced. You cannot do it to just one side. Like, could you just square root one side and be like, oh, it's fine, it's equal? Not equal. All right. So we're going to do this 2 ways here. So we have this b to the x is equal to c. All right, so far so good. We're going to do 2 things to them. Okay, the first one, we're going to change to the log form. And we know how to do that. We've been doing that, right? If you don't know how to do that, practice. Practice this triangle of power. All right, so b to the x, you see b to the x is equal to c, right? There it is in color for you. So again, so this is going to be log base b of c is equal to x. Now, the same equation, b to the x is equal to c, we're going to do something else to it. We're going to log both sides. Okay, so if you notice right here, we're going to just log both sides. So we have log of b to the x is equal to log of c. Okay. And then what do we do with this x? Remember, that's an exponent, right? Remember the powers, the properties from last week from the last lesson? Yeah. And so that one, you just bring it. Remember, this is an exponent. And what is log? An exponent. So it's a power to a power, which means we multiply those two exponents. So the x is multiplying with log b. Okay. So that's how we get that. And then how do we just get x by itself? Just divide log b, and maybe you're like, we can do that? Yeah, because remember, log b is just a number. So how do we get rid of a number from x if they're multiplying? Just divide it out, right? So if you notice right here, so x is equal to log c over log b. And did you know, well, they're both equal to x. If they're both equal to x, that means that these two guys equal each other. Do you see what we get? Log, oh, 1 second. Sorry. Oh, I didn't do the elbow thing. I forgot. I've been at my home too long. So log base b of c is equal to log of c over log of b. Ta-da, we proved it to you. You proved it to yourself. Good job. All right, so this is the change of base formula. All right, so now we're going to take a look at Todd and Danielle. Notice that Todd, okay, again, pause. Take a look at what's going on here. All right, take a time to process this whole thing because it's a lot. Okay, and then unpause. I can't pause it for you. I'm not going to be sitting here for 2 minutes for doing nothing. Just pause me. All right, so if you see right here, the first thing we did, that Todd did, was change the log form, kind of like how we did for the past couple of things, right? Past couple of problems. So we changed the log form. Here's the triangle. And then from there is the change of base, right? We did the change of base formula. So log of 50 over log of 4. And then calculator happened here, right? So this is the calculator. Oh, let me change that color. From here to here's calculator, right? I would practice that on your calculator if you have not yet. And it's really good to practice, and then just add 1 to both sides, and then you get 3.822. Okay, so this is one way to do it. Good job, Todd. So if you look at Danielle, she doesn't do it that way. So if you notice, the big difference here is the logs on both sides. So she took the log on both sides. Okay, so log and log. And then, oh, look at the exponent. Remember, the exponent has to multiply. So here's the multiply on the outside, right? And log 4. Notice that there are parentheses around here. You have to put in the parentheses around here if it is more than just one term. Like this is 2 terms. It has x minus 4. So if you did not put the parentheses in there, it would just be x minus 1 log 4. That means this x is not part of the exponent. And then it becomes a lot more complicated kind of thing to do. Right? We mean the whole entire thing was the exponent. So that's why we have to put the whole thing in parentheses to show that, yes, multiply the whole thing, log 4 with x and the 1. Okay. All right. So now that we talked about that, and what do we have here? Let's go with green. And then notice we're going to divide log 4 on both sides, because notice there's a log 4 right there on the bottom, and there's no log 4 over here on the left, right? So we must have got rid of it somehow. So divide. All right, and then how do we get rid of this minus 1? The way we get rid of all minus 1s, right? Add 1. So there it is right there. And then calculator happens, right? I'm not expecting you to do this in your head because that's insane. It's a lot, right? So here, calculator. You will definitely need your calculator here. You can't do it by yourself unless you have log tables. Did you know that they have log tables? Right. Yeah, before calculators. All right, so which way do you prefer? You prefer Todd's ways or Danielle's ways? Either way is okay. I prefer the shorter way. So right now, Todd's way. But either way is okay. So if you take a look at this one, John, Bobby, Randy, and nope, John, Bobby, and Randy. I don't know why I thought that was another person there. right? They're solving this equation right here. So if you look at John's, again, give yourself time to process, right? Pause me. Right. And then so if you notice, John is using what is he doing? Change of base, right? Not change of base, haha, change, convert to log form, right? So here's 9 to the x plus 4 is equal to 27. So this is literally convert to log form. All right. And then what do we do from there? How do we get that? What did John do? Right, change of base. This sounds an awful lot like Todd's, right? Do you see the similarities? It's exact same steps. And then what do we do from there? We'll calculate, right? And then you're just going to subtract 4 on both sides, right? And then you're going to get negative 2.5. All right, try that out. See if you get that. But these are thumbs up, so these should be correct. All right. And then so let's take a look at Bobby's, right? What does Bobby do? Looks like Bobby is taking the log on both sides, right? Take the log on both sides. Then what? Exponent properties, this exponent right here goes to the front, right? So that's where that is. That this is this part right here, right? And then again, we're going to divide by log base 9 or log 9, or I should say log of 9. There we go, right? That's how they get rid of the log. So all we have left is x plus 4. Do they need the parentheses there still? Nope. And then from there, calculate. And then we're going to just subtract 4 on both sides. And we're going to, again, get the same answer. Okay, so this one is convert. So John's way is convert to log form, which is also Todd's way. Bobby's way is take the log on both sides, which is also Danielle's way, right? Same thing. And Randy does something completely different. What does Randy do? Right, from here to here. He starts out with the same equation, except this person is making the same bases, right? So he knows that 9 is 3 squared, and also that 27 is 3 cubed, right? We just talked about that recently, right? 3 cubed. And if you remember your exponent properties, a power to a power, we multiply them, right? So it's 3, it's right here, 2 times x plus 4, and that better equal 3, right? They have to equal 3. So that's what this is right here. So they're just looking at the exponents. So this is just looking at the exponents. All right, and if you notice, then you just solve like how you would any algebra 1 problem, right? So distribute, and then so they distributed, and then subtract 8, right? So they distributed, subtract 8 to get negative 5, and then divide that by 2, right? You get negative 2.5. Any one of these ways works. Which way do you have to do it? Whichever way you want. I know, choose your own adventure. All right, and we have Amit and Neha. And so if you look right here, ooh, what did Amit do? So take the natural log on both sides. What? So can you do that? Yeah, it doesn't matter what the base is. It could just be natural log. You know, that's the base of E, log base E, right? So that's totally fine. And then remember, so this is kind of like Danielle's way, right? And we took this X and we put it in front, right? So that's where the X is from. And then you just divide both sides by natural log of 24, natural log of 24. And then you get about 0.506. Notice they do a little check here. Yeah, just plug it back in and you should get really close to it. It won't be exact just because we have to round. Like there's no way it's going to be exact. All right. And so that's what you would get. There's your check. Yay. If it's about, we're okay. And same thing with this one. So what did Nea do? Triangle of power, right? So, oh, nope, just kidding. She logged both sides. Did not do the triangle of power. My bad. So she did the log on both sides. And I'm assuming it's the she, but I don't know. Here we go. So here's log on both sides. This is log base 10. So can you do that? Remember, it does not matter which base you use. As long as you're doing the same base on both sides, we're okay. All right. And then remember that exponent goes to the front, right? And then we're going to divide both sides by log of 24. And notice it looks exactly the same as we do on the left, except instead of natural log, we have logs. But does it still give you the same thing? Yeah, crazy, I know, right? So just make sure you always check it. And which, I mean, if it's the same number, it should work, right? So yeah, either way is okay. So some people like to take the natural log because it's, you know, one less letter to write, or just take the log. Either way is okay. All right, we did the first problem A here. Always get the exponential by itself, okay? So 2 to the whatever the exponent is. So that's what we subtract 6 on both sides. Once we do that, then we're going to change to log form, or you can take the log on both sides. It doesn't matter. It's okay. All right. And so we're going to figure that out. And if you notice right here, so is log base 2 of 24 is equal to x minus 5. Again, change of base formula. And then we're just going to add 5. And you should get, that should be your answer right here. Remember, for us, we're going to just normally naturally round it to 4 decimal places, as many. Okay, that's the 10,000ths place. So again, try B, B, C, D, and E. All right, and then check your answers. All right, here again, we're dividing by 7. So that's 2 to the 3x. It's equal to 1, 2, 0, 120. Right, 120 is not a, yeah, it's not perfectly. So I'm going to, shall we log both sides? Should we do the triangle of power? Okay, so here we're going to do the triangle of power. So 2 to the 3x is equal to 120. The next one, I'll do the logs on both sides. And what do we get? Log of base 2 of 120 is equal to 3x, just like that. And we know that this is equal to, I'm just going to put this over here. So this is going to be log of 120, change of base, right? Log of 2 is equal to 3x. So where's my calculator? So we're going to get log of 120, close parentheses, divided by log of 2 is equal to, and then I'm just going to divide that by 3. Divide by 3 is equal to 2.3023. So x is equal to 2.0302. Oh, shoot. I forgot what numbers were. I think it was 23023. Let's check. Oh, yes, there we go. Excellent. 4 decimal places. All right, so the next one, before we can do any of that stuff, we do need to get rid of this 5. So you get 4 to the x minus 3 is equal to 21, right? And then I'm going to log both sides, right? So I'm going to go log of 4. I'm going to put that exponent out in front. Parentheses is equal to log of 21, right? And then I'm going to just divide both sides by log of 4 because I want to get rid of that 4. And then what do I have? X minus 3 is equal to log 21 over log of 4. And then just going to add 3 to both sides. So x is equal to log of 21 over log of 4 plus 3. Well, what is that? I don't know. Let's ask our calculator. Can you calculate Okay, here we go. So here's log of 21, close parentheses, log of 4. And we're going to add 3 to that. So it's 5.1962, since that's a 5. So we said that I was just going to round up. So 51962. So about 51962. There's the answer. All right, moving on. Here we have 10. How to get rid of this 10? I'm going to divide that by 10, divide this by 10. Well, I have 3 to the 2x power over 2 is equal to 36. Now, if you notice, this exponent is only for the 3, not for the 2, because if you notice, there's no parentheses inside of, there's no exponent outside of these parentheses. So this 2x is only for the 3. So which means I still have more to do. I need to multiply this by 2. So I can cancel those out. Yeah, that's a thing. So then what do I have is 3 to the 2x power is equal to 72. All right. We're going to go with change of, what is it called? Power triangle of power. Wait, power of triangle? No, that's not it. All right. So this is going to be log base 3 of 72 is equal to 2x. Right. Notice I cannot use natural log here. Why? Because natural log has a base, is the base of e. So we can only use the log in this case, right? So again, I'll do one other thing I want to do here is I want to just divide this by 2. So let me just divide this by 2. All right, so I get x is equal to, let's try it out. So log divided by, just kidding, go back. Log of 72. So I'm doing this now in my brain, divided by log of 3, right, end parentheses, I'm gonna push enter. That's what it is. Now I'm gonna divide that by 2. See how that goes? So it's gonna be 1.9464. 1.9464. So 1.9464. And our last problem right here, here we go. Subtract the 1. We got 2 times 3 to the 5x power is equal to 54. Now we're not done yet, because we got to divide out the 2. So we get 3 to the 5x is equal to 27. Ooh, I know 27. That one's, I can do that one. So remember 3 to the 5x, 27 is just 3 to the 3rd power, right? Which means these two exponents have to be the same. So x is equal to 3. So if you divide that by 5, x is equal to 3/5 or 0.6, either way. All right, so hopefully you got all there. I will see you later. Have a good one.